Right, we have a midterm coming up on Monday. And that'll be the 25th. So this is just a little quick overview of, you can go into Moodle under the test review downloads and you can find this list and also some example problems. All right, so this is going back a ways, so you do want to be sure to kind of go back and review your notes back to where we started after the last midterm. So we started with couples, which are pure moment. Now the thing with couples are, you know, they're applied here. Let's say we've got something going on like this, and we have a couple here, and let's say that's 200 Newton meters, and let's say that that's we have this dimensioned, and we'll say that this is 3 meters and this is 4 meters. Now if you want to find the reactions there, what you would do, you'd go sum of MA, and you'd have negative 200 Newton meters, and then plus 3 and 4 makes 7 times RB. Okay, now that's just something here that I want to point out about couples is the moment arm is already there in the units. You don't need to add the 3 meters into the couple. It's already there. So you just, the couple affects the entire object equally. So so that would just be 200 Newton meters. It'd be negative because it's clockwise. So that's really all you'd have to do, all right? And then of course you'd add 3 and 4 and get 7 meters for the moment arm on RB. All right, the distributed loads were next. Area of the loading diagram is the total force. So if you have a rectangular loading diagram, like so, the force would act at the centroid of that rectangle, so that would be the area, and that would be the base over 2 over from one side or the other. If you have a right triangular loading diagram, which is fairly common, you would have the area acting there, and that would be, depending on where you measure it from, if you measure it from the right angle, it's the base over 3. If you measure it from the vertex side, it's 2 times the base over 3. Sometimes we get into composite loading diagrams like so. If that's the case, you would break it up into a triangle and a rectangle, because we don't really have a good clean way to get the area of a centroid of a trapezoid. Okay, so the area of the loading diagram is the total force. You then apply it at the centroid of the figure. Okay, resultants, sum of fx, sum of fy, sum of moments, or how you compute a resultant. The resultant force is the square root of the sum of the squares of x and y forces. The angle is the arctan of sum of fx over sum of fy. Remember, there are 2 solutions for this arctan, so you might have to add 180 degrees to your answer. You can also find the offset distance there by taking the moment either divided by fy to get x or fx to get y. Freebody diagrams, decide what you want the object to be, draw a boundary around it, show the forces acting on the body, and then you should know these different types of connections and be able to model them with forces and moments. The one thing about this is don't overthink it. All you do on these things is you start with the object that you've got, and then you look at that. So let's say we got a roller right here on a ramp. All right, so to draw that, you would say, okay, I've got a pin joint here, and a pin joint will now allow the object to move up or down or left or right, so that would lead to an x and a y reaction. And then in this case, we got a roller on a ramp, so you would draw in a force perpendicular to the flat surface, which in this case is the ramp. If that's 70 degrees there, 90 minus 70 will get you 20 degrees for the force angle. And you might have a weight or something here. Don't overthink it. Just look at the connections. Put in forces and couples to represent the motions that the connections prevent. Okay. 2D equilibrium, we want to start with a free body diagram. Use sum of fx is 0, sum of fy is 0, sum of moments is 0. It's very common for this to be the first equation. you want to take a moment about a point with two unknowns directed through it. Quite often that's a pin joint. 3D equilibrium, we got 7 equations there to use. You can use either a 2D approach or more of a vector approach. Trusses, method of joints we've just gone through. That's kind of the typical way to work through a truss. Start at where you have a known force, quite commonly a reaction. So usually you want to find the reactions first and the angles. You have the members of the truss. Start at a point where you know a force and have only 2 unknowns, and start working your way through from joint to joint. Remember, tension pulls on joints, compression pushes on joints. Zero force members, these are the common locations where they occur. Unloaded corners with 2 members, unloaded T's with 3 members, and then this special case here where you've got a collinear force and a third member that would be the 0. These are almost kind of special cases. These ones are kind of special cases of T's really, where instead of a member here you have an applied force. Is another way to think of those. Method of sections, make a cut through the members. You can't cut through the joints. Find the reactions first. The members you cut become forces, then use sum of Fx, sum of Fy, and sum of moments equals 0 to analyze and find the forces in the members. Okay, I've got some review problems here. Let's see. I've got this one here, I think, where you want to find a resultant. And then I've got one where you want to do some equilibrium. And then I've got one basic truss, and then a method of sections. Okay, so that's basically what I've got going on for the review. Those are just some old test questions. Keep in mind that, you know, there is a list here of things, but a good thing I brought up in class here is I can't give you a really hard 3D equilibrium problem on a test because it just takes so much time. So there is kind of some practical considerations that I'm going to have to deal with. The things I would really be comfortable with is you want to be sure that you can do couples and distributed loads. Resultants, you know, they very likely be on the test, even though they were quite a while ago, but remember how to do those. Freebody diagrams, of course, we'll use when we're doing equilibrium. 2D equilibrium will be on there. 3D equilibrium, we'll see. If there is anything on there, it's not going to be that difficult, again, just for the lack of time. Trusses, method of joints will be on there. Method of sections and zero force and all that, maybe a little bit, but I'm not going to have a huge amount of points on that. So the main areas to focus on are the building blocks, the couple and distributed loads, then resultants. Freebody diagrams, again, are kind of a building block on equilibrium. 2D equilibrium, and then method of joints. Those are the main topics to really focus on. But of course, you want to cover all the different areas and review your homework and all that. And also do not make the mistake of just doing the test review and thinking that you're good to go. You know, there's, you know, I can put different things on there that I wouldn't put on the review. So just review all the material to get ready.